Hello class, in this video I'll be showing you how conditional probability can be used to determine the probability of the intersection of two events. Let's begin. We'll start with the product rule. If E and F are events, then the probability of the intersection of E and F may be found by either of these formulas. And I'm going to highlight them now. And notice that each of those formulas contains a conditional probability statement. However, I'm only going to use the formula on the left. And that is so because when we get to Bayes' theorem uses the notation, the probability of F given E. And I don't want to confuse students with what we're doing now and Bayes' theorem later on. So from here on out, I will only be using this formula that's highlighted in yellow. All right, with that said, let's take a look at the example. It says, assume 2 cards are drawn from a standard deck of 52 cards without replacement. Find the probability that an ace and a 4 are drawn. So let's start with the very first part of the directions. It says, assume 2 cards are drawn. Now in previous examples, only 1 card has been drawn and we found the probability of a certain event happening. Now there are 2 cards being drawn, and the stipulation is that we are not replacing the cards after they are selected. So we want to find the probability that when we are done with the experiment, we have an ace in the hand and a 4 in our hand. So that can happen 2 ways. We can select the ace first, then we can select the 4, or we can select the 4 first, then we can select the ace. No matter how it happens, after we're done with the experiment, we have an ace in our hand and a 4 in our hand. So let's start with the statement that I highlighted in blue. The probability that an ace and a 4 are selected is the probability that the ace is selected times the probability that the 4 is selected given the ace has already been selected. All right, let's start with the probability of F. There are 4 aces in a deck of cards, so that will be 4 divided by 52, because all 52 cards are in the deck. Now we want to select the 4, given the ace has already been selected and not replaced. So in this case, we have 1 less card in the deck, so that will be 51. And there are 4 4s in the deck, so that will be 4. And after we reduce the fraction, we're left with 4 divided by 663. So what happens when we select the 4 first? So the probability of E and F is again the probability of F times the probability of E given F. So it's the probability of selecting a 4 times the probability of selecting the ace given the 4 was already selected. So the probability of selecting a 4 first is going to be 4 out of 52. And since we're not replacing the card, we have 1 less card, so that will be 51. And we have to select the ace from the 51 remaining cards, so that'll be 4 divided by 51. And as a reduced fraction, that will be 4 divided by 663. And the final step here is recognizing the fact that since one or the other scenario can occur, we must add the probabilities. So 4 divided by 663 plus 4 divided by 663 is equal to 8 divided by 663, and we are done. Okay. Example 8. Find the probability that 2 black cards are drawn. Okay, so let's take a look here. What I'm going to do is I'm going to let F be the event. The first card is black. And I'm going to let E be the event. The second card is black. And the first thing that I want to realize is that there's only one way to select 2 black cards. So there's no or statement here. There is only one way to select 2 black cards. All right, so we want the probability of E and F is the probability of F times the probability of E given F has already occurred. So the probability that the first card is black is going to be 26 divided by 52, because there are 26 black cards in a deck of 52. Now we want to find the probability that the second card is black given that the first card was black. So since we removed 1 card from the deck, there are 51 cards remaining. Since we removed 1 black card from the deck, there are only 25 black cards remaining. So after we multiply and reduce, the probability is 25 divided by 102, or just under 25%. And we are done.